So Unit 8 is all going to be about right triangle characteristics. So the first section that we're going to start with is actually trigonometric ratios. So trigonometry is really just the study of right triangles, and there's an entire course that is actually based on trigonometry characteristics, and we're just going to get an introduction, okay? So based on what we know about similar triangles, we can have right triangles that are different lengths, but because there is one right angle and all angles add up to 180, the ratio of the sides is going to be proportional, okay? So that's what we learned before. And so what we're going to do next is we're going to learn about a specific ratio of sides that's true for all right triangles. So notice this is only applicable to right triangles, okay? So there are 6 total, but we are only going to talk about the first 3. And typically you want to memorize these ratios. What's nice is there's an acronym that helps with that process, okay? So the 3 trig ratios are called sine, S-I-N-E, cosine, C-O-S-I-N-E, and tangent. Now, if you've ever seen a scientific calculator, you'll see these 3 buttons abbreviated on the calculator. So you'll see it written as sine, and it's talking about an angle. Typically, we let theta, the Greek letter, stand for the angle value, okay? So sine is equal to the ratio of the opposite side divided by the hypotenuse. Now, when you're talking about an angle, you're never going to be talking about a right angle. You're going to be talking about one of the other 2 angles. So if I pick theta, opposite means across, okay? And the hypotenuse is always the side that's across from the right angle. So let's look at cosine. So cosine of our angle is equal to the adjacent side. So adjacent means right next to, okay? And notice it is next to 2 sides, but the side across from the right angle always has to be the hypotenuse. So the hypotenuse will never be labeled as adjacent or opposite, okay? And then the third trig ratio is called tangent, and that's equal to the opposite side divided by the adjacent side. Notice the hypotenuse is not mentioned at all, okay? And so if we abbreviate these, and they've tried to draw them in pink, you get so, ka, toa. And so that kind of tells you the order. Once you say this over and over again, like when I do trig ratios, I actually say so, ka, and I kind of exaggerate it so I know how to spell it, okay? And so that's it. Because these are fractions, you definitely want to reduce. If they are radicals, then you want to break down the radicals if you can. Break down radicals. So we've done a review of that, and we'll keep reviewing it as well. All right? Okay, so let's look at the first 3 examples. Notice on my first example, all 3 sides are labeled with values, and theta is what we want to find. So theta is marked, okay? And so it says tangent of theta. So you have to remember that tangent is toa, so opposite over adjacent. So you're going to locate the angle that they want to use, and then we need to find the side that's opposite. So remember, I always go to my right angle, and I go across, and I write the word HYP for hypotenuse. So that means that 15 is always going to be the hypotenuse, okay? So 12 and 9, those are either going to be opposite or adjacent, but it really depends on the angle that you're trying to find. So if this is my angle, the side that is across from it is labeled as opposite. And the side that it's next to, see how they're right by each other? That is labeled as adjacent. So if we want the tangent of theta, we're going to get the opposite side over the adjacent side. Now, it doesn't matter if they're bigger or smaller on top. You're going to leave your answer as a fraction, but you want to reduce. So both of these numbers divide by 3. So 12 divided by 3 and 9 divided by 3. And so 4/3 is our tangent ratio. Okay? All right. Let's go to our second one. On our second one, it says that we need tangent. So tangent is opposite over adjacent. Well, we know that this is the hypotenuse, and theta is right here, our angle. So across from it, this is our opposite, and the side that it's right next to, this is adjacent, except for we're missing this side. Okay, the problem did not tell us that value. So we need to find it. Now, way back ago, and we kind of reviewed it last unit, we learned about the Pythagorean theorem. So you may need to use the Pythagorean theorem to find the missing side lengths. So remember, it's the two legs, so a squared plus b squared in either order since you're adding, is equal to the hypotenuse, which is c, squared. Okay? Sometimes you'll have an integer answer, sometimes you'll have a radical. So you just get what you get. So first we're going to solve for the missing angle. So I'm just going to let this be a. So we get a squared plus our other side is 14 squared equals c squared, which is 22, our hypotenuse. Okay? So on a quiz, I would definitely want to see this work to find how you're finding the missing value. So 14 squared is 196. So we get a squared plus 196. And then we need to do 22 times 22 or 22 squared. So I got 484. Now we're trying to solve for a. So a is on the left, so I'm going to subtract 196. So a squared equals minus 196, 288. And now you want to try to take the square root. Okay, so on a calculator, if you try the square root of 288, you're going to get 16.97056. You do not want to write a decimal. So remember, what that means is if your calculator gives you a decimal, you need to break this down and look for doubles. Okay? So 288, well, I know it divides by 2. So 2 goes in there 144 times. And then because I've worked with 144, I actually know that that's 12 times 12. At any point, you can take square roots to see like, oh, can I take the square root of 144? Or you could have kept breaking this down by 2s. It's really a choice. So what that means is that the 12 comes out, and since the 2 is single, remember that stays in. And so that's how big side A is. So I'm going to label it on my picture. So this is 12 root 2. So if we want the tangent, we know our opposite side was 14 over our adjacent side is 12 root 2. Now at this stage, we definitely want to reduce the outside numbers. So don't worry about that root 2 yet. Okay, it's just going to stay there for a little while. So both of these numbers divide by 2. So 7 over 6 root 2. Now, if you want to leave your answer like this, honestly, there is no mathematical reason to rationalize. Some mathematicians like it, but I will accept this on a quiz. Now, if you're matching multiple choice, you'll definitely have to be flexible. And so remember way back in quarter 1, we learned about rationalizing square roots. So if we have 7 over 6 root 2, there was a rule, because some people don't like it, that says you can't leave radicals in a denominator. So what you need to do is multiply the denominator by root 2 and the numerator by root 2, because root 2 over root 2 is actually 1. And so we're going to review that. So on top, we would get 7 root 2. Root 2 times root 2 is root 4, which is really just 2. So 6 times 2 is 12. And so this is a rationalized answer. Both of these are mathematically equivalent, which is why, like, if you take calculus, you stop rationalizing. That's why I start thinking, well, do we really need to? To match multiple choice, the answer is yes. But technically, there's a debate in the math world. Okay? So I will take either one on your quiz, just so you know. Okay? And remember, that only has to happen if the radical's in the denominator. All right, let's try example number 3. So Example number 3 says find cosines. Remember, it's so ca, so we get adjacent over hypotenuse. And we need to find theta. So here's theta. So adjacent, well, I'm going to always find my hypotenuse first. So here's my hypotenuse. And adjacent means right next to. So that's adjacent. And that one was opposite. Okay, so all 3 sides should have a name. So adjacent we get is 10 root 2. And the hypotenuse is actually 15. Now remember, the radical stays root 2, but these numbers on the outside I can reduce. So they both divide by 5. So I get 2 root 2 over 3. And since the radical's in the numerator, I leave my answer. This does not need rationalized. Okay? So it really depends on the problem. Some problems are longer than each other if you need to find missing values, if you need to rationalize, things like that. All right, let's try a few more. And I was supposed to take off example 6. I just left it blank, so it is blank. We'll see if anybody has any questions at the Zoom. So on number 4, we're going to do tangent. And notice I have the same numbers. So here's 14 and 22. I have them in different orders. So no, I don't. Okay, I'm going to change that. So let's go ahead and move on to example 5. On example 5, we've got the cosine of theta. Now, because theta is by A, I could also have written this as the cosine of A. All right? So what we need to do is cosine is ca. So I've got adjacent over hypotenuse. Okay? And so here's theta. So right next to it, that's my adjacent. I know this is my opposite, and this is my hypotenuse. So I know my adjacent is 13. What I don't know is my hypotenuse. So we're going to find that with the Pythagorean theorem. I'm going to use this side right here. So we get a squared plus b squared equals our hypotenuse squared. So we get 100 plus 169. I'm going to add these together. And then remember, the opposite of squared is to take the square root. Technically, we do get plus and minus, but because these are side lengths, both sides are going to be positive. So we're going to see, does that work out? If we take the square root of 269 in a calculator, I got 16.401. And so remember, if we get a decimal, that means that we need to break this down and look for doubles. So 269, well, it's not even, so I know I can't divide by 2, but I'm going to take a calculator and I kind of call it the rule of 10. So we're going to divide by 3 and I get a decimal. 269, let's see, 4 is even, 5 definitely not, 6 is even. So none of the even numbers will work because if 2 doesn't divide, then nothing else will divide. Let's try 7. Nope. So 269. 8, no. 9. 11, nope. 13. And what I've done is I've literally, oops. Where are we at? Divide. There we go. 19. So I'm trying all the numbers I can. And so basically, when I did the square root, I got 16. So if you try numbers that are bigger than 16, they're probably not going to work. So I went all the way up to 19 and nothing divided in. So what that means is that C is just root 269. Okay? This doesn't happen a lot, but it does happen. So my hypotenuse is 269. And although that looks like a big number, it doesn't break down. It's a prime number. So once again, I'm okay with this answer on a quiz. But just to be safe, because you never know, like on the ACT or anything else, it might be rationalized. we're going to take the denominator and the numerator and we multiply them both. So we could also write it as 13 root 269. And then remember, a root times a root, since they're doubles, it would just come out. So either one of those would be fine with me. Okay. All right, so go ahead and we've tried tangent and cosine. Sine is going to be the same way. So like, let's say we did this problem. Let's just say I did the sine of theta, because we could. So if I want the sine of theta, remember it's so. So we've got opposite over hypotenuse. And so if this is our angle, we've got the opposite and the hypotenuse is across from the right angle. Now, even though I didn't have that third side, I didn't need it. So I don't find missing sides unless I have to, okay? So both of these divide by 2 and we get 7 over 11. So some of your answers will have radicals, some of your answers will not. Sometimes you have to find missing values, sometimes you don't. I mean, there's so many things set up, okay? Let's try one last problem because you might see this on your homework practice. Let's try something that goes backwards. So let's do A, B, C. And we're going to name these, this is 5, 12, and 13, okay? And so what if I set up a problem and it said that the tangent of what equals 5 over 12, okay? Because there's one question on your homework practice that has like 6 parts and you have to fill in each part using the picture that's given, okay? And so this is what one of the parts looks like. And so the idea is you're given the picture and I need to figure out the tangent of what gives me 5 over 12. So start thinking, tangent is TOA. And so that means the tangent of something is equal to the opposite side over the adjacent. And they told us that that's 5 over 12. So which of these 3 letters has the side opposite as 5 and the side adjacent as 12? And so you only have A, B, or C to choose from, okay? Because those are the angles. So what I do is I go up to my picture and I say, oh, well, that's the hypotenuse. So I'm not really concerned with that. I don't really even need to look there. But I need 5 to be opposite. So I go to my 5 and I say, well, that's opposite of which of these letters? So I go across because opposite means not touching because it's touching B and it's touching A. So opposite is C. And I'm like, oh, well, that works. Is 12 adjacent to that C? And so I look at C and I say, yeah, 12's right next to it. And so it's the tangent of C that gives us 5 over 12. Okay. They might set up, what if I gave you something like 12 over 13, and let's say tangent, and then, I'm sorry, I didn't say tangent. Something of A equals 12 over 13. Whew, I can't talk sometimes. So I go to A, and this is my target. And I say, well, if I have 12, 12 is opposite A. All right. And 13, well, 13 is always the hypotenuse. So which ratio talked about the opposite and the hypotenuse? This was opposite. I'm going to label it down here, and hypotenuse. And so I think, well, that's OH. So what's O? That's so, which is sine. And so I'm looking for sine. Okay. And so you might have to type in the missing parts of the equation. But it's still using the trig ratios in a different way. So notice based on what angle you're looking at, that changes what the words are for the sides. Okay, so you really have to pay attention to what you're looking at, what words they mean, because it's like changing your viewpoint. Okay, so go ahead and give that a try. Email me if you need any help at all. All right.